Hello everyone, my name is Shyam Manawat and I welcome all of you once again to the lecture series of progressions. We are in lecture number 4 in which we are going to discuss sum of infinite term of geometric progression. So let's get started. Sum of infinite term for GP. The formula is first term divided by 1 minus common ratio. This is applied, this formula we can apply, and of course we can find the sum of infinite term only in case of when the common ratio is between -1 to 1. That means something in decimal, 0.5, 0.3, minus 0.3, anything like that. Okay. What is the sum of infinite term for this? So now let's apply the formula in this particular question and get the answer. So here we can say the first term as per the question, is 16, and common ratio is what? Second term divided by first term, and that should be equal to third term divided by second term. Yeah, so the ratio of two consecutive number. Yes, so this is to check whether your progression is geometric progression or not. Although we know we are working on sum of infinite term of geometric progression, this is supposed to be geometric progression, right? If you don't believe so, you can try finding the common ratio between the two consecutive terms and see whether they are same, whether they are common. If yes, then that's the geometric progression. In this case, we will see the second term, which is -8, and the first term is 16. What is the ratio? -half. Or if you look at the third term divided by second term, what do we have here? 4 by -8, that is also -half. So this is to identify whether the progression is geometric progression or not. We did that. It is geometric progression. Can we find out the sum of infinite term here? Yes, we can. What is the formula? Formula is simple. Here is the formula. This is the formula. And you can also see this common ratio. The common ratio is what? -0.5, which is between this range, correct? In that case, we can apply sum of infinite term here, which is first term, we know 16, 1 minus common ratio here is -half. Simplify 16 by 1 plus 1 by 2. 1 plus 1 by 2 is, this will be 3 by 2. Denominator will go in numerator. That becomes 16 into 2 by 3. So 32 by 3 is the answer. Yes, that is sum of infinite in this particular case. I hope this is clear. No confusion. No confusion, right? Okay, let me write this sum of infinite here. Yeah, looking good. Okay, mark the answer. Yes. Okay, sum of infinite. I hope you understood how to apply the formula. Let's see the next question. Next question is quite interesting. Formula is same, sum of infinite for geometric progression. You can pause this video, look at the question and try attempting it by yourself. Question says a rubber ball is dropped from height 64 feet. So let's say here 64 feet rubber ball is dropped from there. Yeah, from here. On each bounce, it becomes 3/4 of the earlier distance. So for each bounce, so now when it bounces back, it goes to 3/4 and then come back, obviously, right? And then again 3/4 and then come back, obviously, right? Question is, find the distance traveled by the ball till it comes to the rest. Here, this is again, keep happening, keep that 3/4 of the height and 3/4 of the distance, and so that's on. So this we can consider it takes infinite time bounce to before it comes to the rest. Yes. So We need to find out the distance. Now, the point the point where you need to pay attention here is this 64, when dropped, this 64 feet distance is covered once. Apart from this distance, which is 3/4 of the previous distance as per the question, 3/4 of the earlier distance. Let's calculate 3/4 of the earlier distance. 3/4 of earlier distance, earlier was 64. If you simplify this is 16 3s are 48. So here this distance is 48 and coming back is also 48. Yes. Similarly, the next distance, this one will be 3/4 of 48 now. The earlier distance, this one is 48, right? So this will be 3/4 of 48. That's how much? 36. Yeah. So bouncing back, going up to 36 feet up and then coming down again 36 feet, right? And then this goes on. Okay, let me not draw a diagram because I'm not very good at that, but I hope you understood. Yeah, this will keep happening, right? So we need to find the total distance till the ball come to the rest. Okay, comes to the rest. Fine. So how will we form the series? This 64 will come only for sum of terms, yeah, sum of the distance, plus this 48 is repeating. I mean, if you look at the distance covered, this is 48 and this is also 48, going back up to height of 48 feet and coming back again same height 48, right? So 48 distance will be covered twice. Similarly, 36 will be covered twice. Are you getting it? Yeah, and so on. Correct? 64 is as it is. I can take 2 common from all, and then I have what? 48 plus 36 plus so on. Yeah. Now, from 48 to 36, we got this when I multiplied this by 3/4. Yeah. So the next term again, it will be multiplied by what? 3/4. So if you try to find out the common ratio in such case, the common ratio here will be 3/4. Do you agree with me? Yeah. If you find the next term, you are multiplying every time by 3/4. Yeah, that's the geometry progression, right? You keep multiplying by the common ratio. Do you agree with me? Yeah. So common ratio, you got 3/4. What should be the first term if I want to count this as geometric progression? First term will not be 64 here because 64 is not repeating it. The series is starting from here. You can see. Yeah. So I will keep 64 as it is, this 2 also as it is. And then I will say, okay, this is geometric progression where the first term is 48 and the common ratio, as I understood and as all of us understood, is 3/4. So what is the formula of sum of infinite in that case of GP? This is identified to be GP. First term divided by 1 minus common ratio. Yeah, that's the sum of infinite, right? Sum of infinite term is what? First term by 1 minus common ratio, correct? Yeah. Here the key point for you to understand, why are we counting 64 only once and rest all terms twice? You need to understand, because it drops from 64, so 64 feet will be covered only one time, right? Okay, simplify this further to multiply. Now see, I know my students are smart enough in calculation, smarter than me sometimes, many times, not sometime, many times. Yes, please, you guys should help me out in doing the calculation. Yeah, so it will be 48. Denominator will become numerator, and this is 4 minus 3 will be 1 as it is. Okay, now you simplify. What do you get? 64 plus 2 into 48 into 4. That will get you 448. Yes, that will be the answer. Yeah, I hope you will be able to do this calculation. 2 multiplied by 48 multiplied by 4. Yeah, and then add 64. You will get 448. Yes. Apart from this, did you understand the concept? Is the concept easy to understand? Yes? Great. Let's look at the next question. You can rewind this question and look at the question again. Okay, this is very interesting question. Question number 2 was really interesting questions. You can do that. You can rewind this part and watch it again. Let's see question number 3. This is little different. It will be part of a geometric progression question itself, but you know, this is a specific case where you find a digit repeating, you know, 8, then next term become 88, the next term become 888, next term become what? 8888, and it goes on. Yeah, you will find some repetition of digit. Now, if you look at this process, if you look at this progression in itself is not geometric progression as of now. But if you find this kind of series, this kind of progression, you can make them, you can convert them in geometric progression. So let's see how does it work. Whenever you find this kind of specific case, what you do? You take, so let me write this here, 8, and we need to find sum, right? Sum of n terms. It cannot be infinite because you can see the number is increasing. So if we go up till infinite, it will become infinite. Did you understand? When the number is increasing. Look at the previous 2 questions. Number is decreasing. Yeah, 16, minus 8, 4, minus 2, 1, and then it keeps on decreasing. So the infinite term, the last term will become 0. It will become tends to 0, right? So in that case, it is possible to find the sum. But when the series is increasing, in geometric progression, if series is increasing, then the infinite term in itself be infinite. Yeah, and then if you add all of them, it will remain infinite, not defined. Yes, so that's why this we understood this, that infinite sum of infinite term is possible when r is less than 1 or more than -1. So r is in decimal. So if you multiply 0.5, 0.2 in any number, it will keep on reducing. So this concept should be clear. All good? Okay. Now, if you find this kind of series, so here we need to find out sum of n, which is 8 plus 8, 8 plus 8, 8, 8 plus 8, 8, 8, 8 plus so on. Now what you do? In this case, I advise first of all take the digit which is repeating, take it common from all. Now what is remaining? 1 plus 1 1 plus 1 1 1. Pay attention, okay? This is specific case and this method will be applied only for this particular type of question. Okay. Now what you do? You multiply this by 9 and divide this by 9. Yeah? You multiply by 9 by 9. That means basically you are multiplying by 1. It will not make any change in the answer as such. Mathematically you are multiplying only by 1. Yes. Now this denominator 9 you keep it with you and this numerator 9 you multiply inside the bracket. So inside the bracket it will look like what? 9 plus 9 9 plus 9 9 9 plus 9 9 9 9. Are you getting this? Now what you do? You keep this 8 by 9 as it is, and now all these 9 which are having n times, yeah, for each term. Now look at this, each term, this 9, I write this 9 as 10 minus 1. Okay, this 99 as 100 minus 1, this 999 as 1000 minus 1, and this one, the 9999 as 10,000 minus 1. Now think logically and tell me one thing. Be it 8 plus 88 plus 888 plus 8888, or be it 7 plus 77 plus 777 plus 7777 plus so that so on. This will keep, this steps will be same. You will take 7 common in this case, right? So that's why I'm saying that this particular method will be applicable for this specific type of question where you find the repetition of digits and progressing. Okay, we are not done yet. Now, you understand we need to find out sum of n terms. Yeah, so you got n terms here. Now look at this. I will take all this -1 from each term. Yeah, this 9, first term -1, second term -1, third term -1, fourth term -1, and this -1 I will take n times. This -1 I will take what? And this -1 will be there with you n times. Do you agree with me? So -1 will become -2, -1 -1 3 times it will become -3. If it is 4 times it will become -4, but if it is n times it will become what? -n. Yeah, so I have taken all this -1 together and I have put it here as -n. Is that clear? Okay, now what are you left with? You are left with 10 plus 10 square, that's 100, or let me write 100 as it is. Then 1000, which is 10 cube, plus 10,000, which is 10 to the power 4, and so that so on. Now, do you see this part of the question as a geometric progression, where the first term is 10 and the common ratio is also 10 because you are multiplying 10 to get the next term? Yeah, you see the common ratio, the ratio between any two consecutive terms here, you will get common ratio as 10. Yes? Okay, if yes, then can we apply sum of n terms there? So I have 8 by n, and then sum of n terms if I apply, the formula is a bracket r, which is 10 here, to the power n minus 1 by 10 minus 1, r minus 1 minus n. Yes? Yeah, this is where you get the answer. Now you can look at the option if they have given, if the given options are further simplification of these terms, this expression, then we can further simplify this. But you got the answer here. This is the final step as per me. Like you can do 10, maximum you can do 10 minus 1 and write as 9. Yeah, so you got 8 by 9, and then you got what? 10 raised to n minus 1 by 9 minus 1 minus n. Okay, now further simplification, it will be depending on the option which is given into you in the question. But although this is where we got the answer. Yeah, n terms. I know it looks scary, but if you follow step by step, it's very simple. You can generalize this for every question which is having this kind of repetition. You take this repetition digit, which whatever it is common, multiply by 9, the numerator 9 you multiply inside the bracket, and the denominator 9 you keep it as it is. You will find always this 9, 9, 9, 9 and 9, so that so on. Every 9 you can split that as, you can write it as 10 minus 1, 100 minus 1, 1000 minus 1, and so that so on. This bracket will be same for all such kind of question. Okay, so what I want you to do is, I want you to do the same question, and this time you do it for let's say 3. Okay, so the sequence is 3, 33, then 333, and then 3333. Yeah, you need to find n terms for this. Tell me what should be the answer. Although by looking at this expression here, you can write the answer directly, but I still want you to give it a shot. Yeah, solve this and write the answer in the comment box. I know it will be difficult to write in this way, but try. All right. Okay, so this is it in the lecture number 4 of progression, sum of infinite for geometric progression. In next lecture, lecture number 5, we are going to discuss another progression, that is AGP, arithmetico-geometric progression. That means progression which has arithmetic progression as well as geometric progression in each term. Yeah, so we will solve these kind of question in the next lecture. So I will see you there in the next lecture. My name is Shyam Manavat, signing off. I will see you in the next lecture. Till then, stay happy, stay healthy, and keep learning. Bye bye.